Hey everybody, the techdraw workbench is for producing technical drawings, which I guess kind of goes without saying. Technical drawings are 2D representations of your 3D objects. I've had a chance to use the techdraw workbench in the past. In fact, I included a chapter on it in the book, but I never really dug down into the details, and there were plenty of features in there that I'd never used. And recently I got the chance to do that. I was working on a drawing for a client, and I got to see some more of those features, and kind of made me think that it might be time to do a series of videos digging into the details on this. So we're going to go through 4, 5, maybe even 6 videos and kind of flesh out everything that's in there. So if you want to learn more about FreeCAD's techdraw workbench, well, you've come to the right place. I have on my screen a sample drawing that's kind of I don't know, maybe a motor mount or something like that. It's got a bolt circle around a center bore with a couple of slots in it, and I put some chamfers on the corner. This isn't a real part, but it has enough features for us to play with the techdraw workbench. When you switch to the techdraw workbench the first time, almost everything is going to be grayed out. There'll be no enabled tools at all except for these two. One of them has the tooltip that says insert a default drawing, and the other is about inserting a new page using a template. And both of them really do the same thing. They create a page and assign a template to it. The difference is that the orange one lets you pick the template that gets used, and the other one uses the default template that you've already picked. So if you do a lot of drawings over and over again, it makes sense to configure a default one. So that one it'll save you a couple of mouse clicks to get set up. Now, FreeCAD ships with a handful of templates, and the templates are all SVG files that can be drawn in Inkscape. And in a later video, I'm actually going to show you how to configure your own template and customize it. For right now, we're going to use the US letter landscape blank. And when I select that, it opens up a new MDI window at the bottom with the page. And it adds a new node to the tree for the page, and it also enables a few new tools on the toolbar. Looking at the page node and opening it up, there's a template node underneath it. And if you look at the template node properties on the data side, you'll see that it has the width and height properties, but these are grayed out. This is actually coming directly from the template itself. And the template corresponds to the actual page that's going to get printed out, like the physical piece of paper. And it's really important that you use the correct template for the printer that you're going to print out on. For instance, A4 is very close to US letter, but not exactly. So if I used the A4 template and then tried to print it out on my printer on US letter paper, my printer driver would rescale it to fit, and my drawings would actually, the scale would be incorrect. It would stretch it and squash it in order to fit on the page, and I wouldn't get an accurate representation of it. So you definitely want to use a template that's specifically for the size paper that you're going to print out on. If I have a drawing in process and I make the mistake, I can still switch the template after the fact. There's a template property right here on that template node, and it's got a pick button, and I can go right back in and choose a different template if I wanted to. Choosing the A4 template brings in one that has the margin markers and the data block, and I can switch back again, and I'm going to stick with that US letter landscape blank for right now. Templates themselves are useless. What you need is a view of your part, and we're going to start inserting views into this blank page. Switch over to your drawing and set the view to top view, so we're looking straight down along the Z-axis. Then switch back to page. Make sure that the part is selected in the tree, and click on this insert view in the page, and you'll get the view inserted right here, and it'll have a dotted line indicating the boundaries of the view. And it'll get, I believe it gets inserted directly into the middle of the page. You can then click on this boundary and you can move it around as you wish to position it anywhere on the page. Now the view that came in is, it takes its view perspective from the view that we had here. So if I set the view like this way, looking at my part from an angle, and I do the same thing, coming over here, selecting the part in the tree, and clicking the button, you'll see that the view that I get is from that perspective. Now, you can adjust that after the fact, but it's really easier to just set your view this way, the way that you want it, and then insert it from there. Now, there is a bit of an exception to what I just said. Besides aligning your view this way, instead of selecting the whole part, you can select a face. For instance, if I select this face here and switch to my page and insert the view, you'll see that it directly aligns along the normal of that face rather than aligning to the view as it was of the camera over here. So that's a bit of a shortcut. If you know what you want, you can do it that way. Part views are not the only thing that you can insert into a techdraw page. You have a number of other options here on the toolbar. One of these is a spreadsheet, and I've already got a spreadsheet that's controlling some of the dimensions of my part. So if I select the spreadsheet in the tree and click that button, I'll get a what looks like a view, and it has properties as well. The cell start and end properties kind of control the corners of the box. So I think I go from A1 to B5. And when I refresh the page, it will adjust to show me all of those cells in that view. Objects that are created in the draft workbench are already 2D, and they can be inserted into a techdraw page using this icon here. For instance, I have a shape string object that I created, and I can insert it just like a regular view and put it on the page like that. If you want to insert arbitrary text into your drawing, for instance, a text description of some feature or something like that, a better alternative is the annotation, which is created with this button here. Clicking it creates the annotation object, which can be drug around the page and positioned like anything else. To edit the text, you go to the text field on the Data tab, click the button, and it'll open the editor where you can put in anything you want. And there you've got an annotation that can be positioned like anything else. There's also the opportunity to insert an arch section plane. And this is not a tutorial on arch, and so I'm not going to dive into that one. But it works exactly like the others. Assuming you've already have an arch section plane created, you just select it and place it in, and it'll have a set of properties specific to a section plane. It makes it easier to create those kinds of views, but maybe when I do a tutorial series on arch, I'll dive into that. We have two more icons on the toolbar for a section view, which is different than an arch section, and a detail view. And I'm going to cover both of those in a later video so we can get into a little bit more detail on them. The view gets inserted underneath the page along with the template, and the view has its own properties as well. For instance, I have this X and Y property which correspond to the position that I established by dragging it. I also have a property here for the scale. So if I want this to be larger, I can do that, and when I refresh the drawing, the view will be scaled up to match. You have a number of options to control what's actually seen. For instance, there may be hidden lines or interior lines that you either want to be seen or don't want to be seen, and those can be turned off and on here. For instance, a seam refers to that line around a sphere, indicates an edge that's not really there. Now switching over to the View tab and looking at the properties there, and I know this gets a little bit confusing because we're using the word view in several different ways. We have the view of the part, and then we have the view properties of the view that we're looking at. I don't know, sometimes naming things gets really hard. Anyway, looking at the view properties in the property viewer, There's a couple things here that are probably useful to you. One, you can turn on a horizontal line and a vertical line. If I set these to true, you'll see these sort of light gray dotted lines through the middle of the part. And this can be helpful if you want to align one view to another along the center line. These lines will print out on the output, so if you don't want them to show up on the output, you need to turn those back off again. There's one more section of properties on the View tab that I'm going to talk about, and that's this section at the bottom, lines. The properties here control the thickness of the lines as they're printed or displayed on the paper. And for instance, line width is set to 0.7 by default, and those lines look, well, they look kind of heavy or chunky to my eyes, so I tend to run this back down to like 0.4. And it looks just a little better to my eyes. Now I know that the production of technical drawings is a whole discipline unto itself, that there's a lot of standards out there for how things should be done, and techdraw goes out of its way to comply with those standards very closely. And so adjusting these line widths might, I might be violating a standard there, but I'm not always using them to produce an actual technical drawing for somebody else to read. In fact, there's one example of how you can use something like this that I think is very handy for hobbyists working in the shop. Create a page using a blank template and making sure that the template size exactly matches your paper as discussed. And create a view of your part looking down on it from above. Go to the data properties and make sure that the scale is set to 1.0. That way, when the page is printed out, the scale of the view will exactly match the scale of the part. Before you do this, you probably want to go to the View tab and make sure that the line width is pretty thin, maybe around, a quarter of a millimeter or so. Print out the page and cut out the view using a pair of scissors. This can now be glued to the face of a piece of stock to use as a cutting template and rough the part out of the material. The center points in the holes can be used as an indicator where to center punch in order to give the drill bit a place to accurately begin. You'll get much more accurate positioning of your holes than trying to do it by hand. So one of the best things about the techdraw workbench is that the drawings you create are linked directly to your underlying geometry. So if you go back in and modify your sketches or change your solids, the drawings will update to reflect the changes. And that's not just true for the views, but also for the spreadsheets and for the dimensions, which we're going to look at in the next video. So if you want to deep dive into dimensions, stay tuned for the next one. And if you have comments or any tips or tricks about using techdraw workbench, please leave them down below, and we'll see you in the next video. Thanks for watching.